Hey everyone, this video is going to be on lathe programming, grooving, parting, and threading. We're going to be using code G75 for our grooving cycles. You can find this information on pages 106 through 108 in our text. G75 can be used as a single peck at one location to be like a cutoff tool, or you can program it to do a pecking cycle to do wider grooves. Alright, just remember that anytime that you're parting, you can go to x0 or x-0, any negative value. But if you program to a negative value, or if you program to 0, you'll most likely break off of your stock, resulting in damage of your workpiece falling in the machine. Sometimes people like to program to a low positive number and then break the piece off by hand. Setting up with the machine, and you need to know your tool position and your touch off. You must also know the cutter width and the edge that you're referencing for your touch off. What to expect in the line of code: an X, Z, I, and K value, and also an F. A couple different ways to see the code. The one on the left is going to be a single groove / part off, and the code on the right will be for a wide groove or multiple steps. This footage here is going to be using our Haas simulator and be using G75 for a single groove. You'll see I am going through the code here in MDI, then I will show the code in graphics, and then I will run the code as I am running the program at the machine. This view here is also on our Haas simulator and also using G75, but this is going to be for a multi-groove. So I'm going to be doing some step overs to create a bigger width slot than just the normal width of the cutter. Now that we have some grooves that we can put into our workpiece, aka cutting thread reliefs, we will get into threading. This is on page 109 in our text. We'll be using G76 for our multiple pass thread cutting cycle, and the variables for this cycle include X, Z, K, D, and F. An example how to use this code, I call out my tool, I turn on the spindle, and then I wrap it to a safe location. I'm cutting a half 13 thread, and then I put my G76 code in with the cutting parameters that accompany it. My X variable is the root diameter, the Z is the thread endpoint, K is the height of the thread, this increment is radial, and this is the basic major diameter, subtract from the basic minor diameter, and then divided by 2 because it's radial. D is the first pass cutting depth. You can get more information on this on page 113 in your text. And our last variable is going to be the feed rate. This is calculated by the lead, which is going to be the amount of threads per inch. So you have 1 inch divided by 13, the number of threads per inch, and we get 0.076923077. Now we want to take this decimal out to at least 5-6 places. We also have some information on thread finish passes. This is on page 129 in your text. This code can be used for simple or single pass threading. G92 is a modal code, meaning that you can do multiple passes with a new X value. The code looks like the following on the bottom of this page. This next slide is going to show you how to program the code, continuing with the half 13 thread. And we're going to use G76 and G92. For the G76, you're going to increase your X value and then use G92 to work towards the root diameter. So you can see here how the X value for G76 is a little bit bigger, and then G92 it gets smaller by 1.5 thou, and then the final line is a spring pass. last part of this video, we'll be using our Haas simulator for CNC threading. We'll be using a G76 cycle and then a G92. You'll be able to see it in the MDI code and then when I go through graphics.